Hello everyone and welcome. In this video we're going to be talking about how rotary engines work, and in front of me I have a 13B Wankel engine out of a 1985 Mazda RX-7. So to start things off, we're just going to be talking about all of the different components in here, then we'll be talking about how the combustion cycle works, and then from there we'll talk about some of the different unique features on this engine and then get into the advantages of this design. So just starting on the right here and then working our way across, this is the front plate. Here we have the rotor housing for the first rotor. We've got the center plate, the second rotor housing, and then the rear plate. Now the 13B is a two-rotor design, so here we have the two rotors. These are the rotary equivalents of pistons. And finally we have what is called the eccentric shaft, and this is essentially the crankshaft but for a rotary engine, and so this is what your two rotors are going to be connecting up to and ultimately trying to rotate. So getting into how combustion works, we're going to be looking inside of this rotor housing, and what we have here are the intake ports. So as the rotor rotates over this, it's going to be drawing a vacuum and pulling air out from these ports. And it's important to realize that there's ports on both sides, so both the back plate and the center plate have ports, and so air will be drawn in from both sides into the combustion chamber. Moving right along here, you have the two holes for your spark plugs, and there's going to be two spark plugs used, which we'll get into in a bit, but basically it's because the rotor is going to be rotating and the combustion chamber is really long, so you're trying to speed up the process of combusting that air-fuel mixture. And then finally, as that rotor rotates, it will press the gas out through the exhaust port, which you can see here. So now let's work our way through the 4 cycles which need to occur for combustion. So first we're going to be starting with an empty pocket. So as you can see, the rotor's completely up against the rotor housing and there's no air in there. As it begins to rotate, however, it starts to open up a pocket and this creates a vacuum. And as it continues to rotate, that vacuum opens up to the intake ports, allowing you to draw in air and fuel. That continues to rotate, and then eventually you start to fill up this entire chamber, and then you close off the intake ports, and now you've begun compression. So now this chamber is going to start squeezing down that air and fuel mixture into a smaller chamber until it reaches the equivalent of top dead center, which is about right there. And so you can see you've got this really small pocket, and so now your two spark plugs are going to fire, and it's going to continue to rotate, and combustion is going to force this rotor to rotate in this direction, as you can see expanding that pocket. And then finally you will open up to the exhaust port, where that exhaust can then dump out, and the rotor continues to rotate, forcing out all of that exhaust, and then the cycle repeats itself. So looking on the side of the engine, you can see the intake ports. So in the center, for the center plate, it's going to divide between them. So this will go to the rear housing, and then this one will go to the front housing. And then you've got these two intake ports on either side, which will also feed into these rotor housings. Now as you continue down, you've got the exhaust ports, so one for each housing. Now it's important to realize that at any moment within this rotor housing you have multiple stages of combustion occurring. So you've got the initial cycle right here where you've got intake, you've got compression happening right here, and then you've got your exhaust stroke occurring right here. And all of these are occurring simultaneously when the rotor is in this position. Now if you were to continue to rotate it, here you're going to be having your spark, there you're going to have the exhaust, and here you're going to be having your intake stroke. As you continue to rotate that rotor, here you can see combustion occurring, we have our exhaust occurring, and then we're starting to exit the intake stroke and start to get into the compression stroke. And when the rotor is in this position, here we have our compression occurring, here we have our combustion, and the exhaust is finishing up, and then the intake is just beginning. Now it's also important to realize that while all this is occurring in one rotor, in the other rotor, the rotor is exactly 180 degrees offset from this rotor, and so the opposite is going to be occurring in here. So you're about to start your combustion with the sparks firing, you're ending your exhaust stroke over here, and you're starting with your intake stroke over here. So here we have the eccentric shaft, and as you can see, these rotors are going to be placed at 180 degrees apart. And that's done so that it balances on that axis. So as this rotates, it's going to be well balanced, rather than if it was offset, it wouldn't be balanced. Now you will still have a moment occurring because you've got one rotor going this direction and another going this direction simultaneously, but because all of this is rotational and because it's balanced vertically along the axis, it's going to be a very smooth, very low vibration running engine. So let's see if we can make sense of how this will work out. So here we have our rotor, which will be on one end, and then our eccentric shaft, which will go inside of that. And then our other rotor is going to go onto the other lobe. And of course it's going to be offset 180 degrees. So it's going to look something like that. And so you can see that the inside of this rotor has this gear, and so this gear is actually going to mesh up with this stationary gear. And so as that rotor rotates, it's going to force the eccentric shaft to rotate because this is stationary. So that gear is going to mesh with this gear and then force that lobe to turn, as you can see demonstrated somewhat there. Now this stationary gear is going to go on the outside of the front plate, and so there it's going to bolt up so it's not going to move, and then on the other side you can see that gear will come through and mesh up with that internal gear of the rotor. Okay, so now that we understand how combustion works in a rotary engine, let's take a look at some of the unique features to this engine design. So you'll notice right here on the intake side of the rotor housing this little hole, and this isn't actually for fuel. In fact, it's for motor oil, and the reason this is done is to inject oil in here in order to help lubricate the seals. Unlike a piston cylinder engine, you can't spray oil up on the bottom of the pistons to help create a seal there and help lubricate things, so it's actually done directly within the housing. And you actually have injectors that also inject in oil with the air-fuel mixture as well. So looking at this on the other side, that's what I'm showing right here. So this is where you're going to have your little oil injector, and this is the pump which you would be hooking up these oil injectors to these certain locations where they'd be injecting oil. And this is essentially throttle controlled, so as you press on the gas, it opens up and injects more oil. So by design, you're going to be burning oil. So one of the other unique challenges to the Wankel engine is how to seal it. And so you have to keep in mind that you want to keep the combustion chamber from crossing over from one side to another, from here to here, but you also don't want any crossing over this direction outside of it. So you have to seal it this way, and you have to seal it at all these three edges. And so the way they do that is they use these apex seals. And so these apex seals, it's actually a two-piece design for this 13B engine, and so it'll be something like that. And these will slide in here and they will press up against the housing. And so the way that it continues to be pressed up against that housing is using this spring. So this is essentially like a leaf spring, and it goes on like that. There's a little notch for it to hold it in, and then you can slide that down in there, and that spring will press this apex seal out against the housing so that you maintain a seal as this rotates around. And so here's a little bit of a better view. You can see you've got the apex seal. It's got a little notch there at the bottom, and so that spring will line up with that notch. And then you've got the top piece of the apex seal, and that'll be right there on the top. And it also has a notch to hold the top of the spring in. And so you'll have your apex seal in there. You can slide that spring down in with it, and that will help keep it pressed out. Then you've got the top portion of the apex seal. And then you have this little piece right here, which will hold that all together. Now, as I mentioned, you also have to seal off so that nothing comes over this side. So you have these side seals, which can get inserted into these little grooves here. And so the way that those are maintained up against the housing is that you have this spring. So you can see it's rounded if you look at it from one side, but it's actually a spring if you look at it from the side. So that will get placed down into that groove, and then you'll place the side seal over that, and that will maintain pressure up against the housing. And then finally you have your face seals, which will be resting in here, somewhat similar in idea to piston rings. And of course you have to maintain pressure against the housing as well. So you've got this spring right here. You can see a perfect circle, but if you look at it from the side, it's got these bends in it so that it creates pressure. So that will slide in there, and then you put your ring on top of it, and it maintains pressure against the housing. Now, one of the things you may have noticed are these drill holes, and so after the rotor has been manufactured, you want to make sure it's balanced. And so you'll put it on a machine, you can spin it, and you can see how out of balance it is, and then you can drill holes accordingly in order to make sure it's balanced. So you can see that on both sides being done in order to balance out the rotor. Another interesting thing you'll notice on the rotors are these concave pockets. And so what these do, by removing material from the rotor, you increase the displacement of the engine. Now let's get into the various advantages of using a rotary engine versus using a piston cylinder engine. And so one of the first things you probably notice is that there's very few moving parts. 1, 2, 3. That's it, 3 moving parts. It's an extremely simple design which has its own benefits of being simple, and because it's very simple, it can also be made very reliable. Another advantage is the fact that there's no reciprocating mass. All of this is always rotating. So one of the disadvantages with piston cylinder engines is that when you have reciprocating mass, such as the valves which are going up and down, you can have valve float. And because of valve float, you can't rev to higher RPMs. So an engine like this can rev extremely high because it's not limited by a reciprocating mass. The other thing to note with rotational mass versus having reciprocating mass is that it's going to be very low vibration. So it's a very smooth running engine. One more advantage is that it has extremely smooth power delivery, and that has to do with the fact that there's one power stroke for every revolution of this eccentric shaft for each rotor. And so let's kind of look at a demo of how this works. Now, one thing you'll want to notice is that with this rotor, the way it's geared to the eccentric shaft is that for every full rotation of this rotor, it's going to rotate the eccentric shaft 3 times, and that's just simply based on the gearing. Now, the other thing we want to understand is that for every time this rotor rotates 1 full time around, you're going to have combustion occur 3 times. So let's take a look at it. Here you can see we've got these 2 parts drilled out, and here it's a flat surface. So we're going to be paying attention to this spot and rotating around 1 full time and see how many times combustion occurs. So right here we have our 2 spark plugs. So this is going to be our first combustion, which is going to be occurring in here as that rotates. And so there you have that. And then you press that out. There, as you can see, is our second combustion. And so that's continuing on. And then we're going to get into our third combustion. So here we are igniting our third combustion. Here's that F that we were paying attention to. So we're marking when this gets back to here. And so as you can see, it finishes up back in that spot, and you've had combustion occur 3 times. Now, this is different from a piston cylinder design with 4 strokes because with a 4-stroke engine, for every 2 rotations of the crankshaft, you're only going to have 1 combustion cycle. So for this, for every rotation of the eccentric shaft, you're going to have combustion occur. As a result of this, power delivery is going to be much smoother. And finally, another huge advantage of the Wankel engine is just how compact it is. So as you can see, it's about 1 foot long, it's about 1 foot wide, and it's about 1 foot tall. So all of this occurring within about 1 cubic foot, a very compact engine, and you can fit a lot of power in a very small, light form, and that gives you a lot of options for packaging. So it's great from that sense as far as how small it is. And I also want to say thank you to Sean for letting me borrow his rotary engine. Thank you guys for watching, and if you have any questions or comments, feel free to leave them below.